discuss how to solve right triangles. And essentially what that means is we want to figure out what all three sides and all three angles are in the triangle. And we're going to have two main ways to do that. For the sides, we know that a squared plus b squared has to be equal to c squared. And for the angles, a plus b need to add up to be 90 degrees. Since we know that the total triangle is 180, and we've already accounted for one 90-degree angle. Let's consider this triangle. We're going to start by finding the missing angle, which we're going to call b. We know that a plus b needs to be equal to 90 degrees, which tells us that our angle b is 40 degrees. We also need to find sides A and C, and we can now do that. We're going to start with side A and the fact that we already know some of our triangle. Essentially, I'm going to look at the fact that tangent of 50 degrees is equal to opposite over adjacent. And now we can work this out to figure out what we need for our missing side A. We can see that tangent of 50 degrees is approximately 1.12 equal to a over 3. Multiplying both sides by 3 then gives us approximately 3.58 equal to a. And depending on how you rounded, your answer may be slightly different than mine. I actually never rounded until my final answer. Now that we have that, we can find c using the fact that a squared plus c squared, or plus b squared, will be equal to c squared. So we can square this side we just found. Plus 9 gives us approximately 21.78 equal to c squared. And then take the square root of that to get that c is going to be approximately 4.67. And now I have all three angles and all three sides. We have another one here. We can easily find our angle A by saying that 90 degrees should be equal to 25 degrees plus a degrees. Subtracting from both sides gives us that a is going to be 65 degrees. If we then want to find b, we can use the fact that tangent of 25 degrees is opposite over adjacent, and then we can solve this equation. We start with tangent of 25, which is approximately 0.47. We can then multiply by the denominator of 7 to get 3.26 is equal to b. Finally, we need side C, and we'll do this with the fact that we have a squared, which is 7 squared, plus this 3.26 squared should be equal to c squared. On the left-hand side, we can work that out and get approximately 59.65. And then we can take the square root to get that c should be 7.72. So now I have all the information. For this one, we don't know either angle. We'll call them A and B. And we're also missing side C. We can use the Pythagorean Theorem to say that c squared is equal to 5 squared plus 8 squared. And then realize that on the right-hand side of that, 25 plus 64 is 89. And then taking the square root of 89 gives us that c is approximately 9.43. To find our angles, we're going to use trig functions. I'll start with angle A, And we know that tangent of A is equal to opposite over adjacent. 8 divided by 5, we can work out fairly easily and get 1.6. And previously, in a different video, I had pointed out this button on the calculator that says tan -1 and said that that would come in handy later. If we know what the tangent of an angle is, pressing this button gives us the value of the actual angle. So we can do tan inverse of 1.6. And when we do, that's approximately 57.99 degrees. We can then do that plus our missing angle B needs to be equal to 90 degrees to get angle B, which will essentially be 90 minus this 57.99, which is 32.01 degrees. So these are all three sides now and all three angles. Once again, here we have two sides and no angles. So I can start by finding C using the fact that this is equal to 3 squared plus 5 squared. Therefore, C squared is 9 plus 25, which means C squared will be 34. And then using that, we can find C by just taking the square root of 34 to get approximately 5.83. To find angle A, I'll use the fact that tangent of A is opposite over adjacent. We know that 5 divided by 3 is 1.67, and then using the inverse tan button on the calculator, the A to the -1, we get that this angle is approximately 59.04 degrees. We can then do 59.04 plus our missing angle B is equal to 90. So then if we subtract 90 minus 59.04, we get angle B, which is 30.96. Next, we'll consider a little bit of a word problem. Let's suppose we have a building, and we have a ladder leaning up against this building. We know that the ladder is 5 meters long, and the angle it makes with the ground is 55 degrees. And we want to know how far up the ladder is and the distance from the base. So we want to know these two numbers here. Well, I can use, really, in reality, I've been using tangent a lot, but you can use any trig function. In this case, we want to use anything but tangent or cotangent, since that would involve both sides we don't know. I'm going to start with sine of 55 degrees, which is opposite over hypotenuse. And then we can find the value for A. We'll start with 55 and the sine of that, which is 0.819. Multiplying by 5 then gives me that the ladder is approximately 4.1 meters up. The next question was how far it is from this base of the building. In this case, I'm going to use cosine of 55 degrees, since that involves my adjacent side and my hypotenuse. So we start with cosine of 55, which is 0.57. And then multiplying by 5 gives me that it's approximately 2.87 meters from the side of the building. One last one. We're going to consider an airplane flying, and the fact that it starts at a bearing of north 30 degrees east. So essentially, anytime we're dealing with a bearing, this tells us our angle from the x-axis here, or from the y-axis rather, and so we know that this is 30 degrees in the east direction. We then know that this this plane flew for 1 hour and then turned 90 degrees and flew for an additional 3 hours. And we want to find its new angle. So essentially, I'm looking for this big angle here to start with, since that's the angle in this triangle. In this case, we know the adjacent and the opposite side, so we'll use tangent. And tangent of this theta is opposite over adjacent. So now we just need inverse tangent of 3. And when we do that, we get that this big angle is 71.57. However, that's not really what we wanted. Really what I wanted was this smaller angle here, which is going to come from the angle in the big triangle minus the 30 degrees that we had originally. So the new bearing would be north 41.57, west, since we're now moving in the west direction.